Okay, in this lesson 5, you're going to learn about interior angle sum of a polygon, and you're going to learn about the exterior angles of a polygon and their sum. So the first thing we're going to do is we're going to write down in our interactive notebooks interior angle sum of a polygon. So interior angle sum of a polygon. And remember in class we talked about what polygons were. They were closed figures with straight sides with 3 or more straight sides. So the sum of the measures of the interior angles of a polygon is the number of sides minus 2 times 180. So we're going to write that down. The sum of the measures of the interior angles of any polygon is number of sides minus 2, so that can all be in parentheses, times 180. And that will give you the total number of degrees for the polygon's interior angles total. So for example, the symbol that you'll see is S, or the sum, equals, and I'll write sum, that's what that means, equals N, or number of sides, minus 2 times 180, because 180 represents the interior, the sum of the interior angles of a triangle. Okay, so let's do an example with this. We're first going to use a quadrilateral as an example. So you're going to write down example 1. So example number 1, we're going to use a quadrilateral. In this case, it's a rectangle. And we're going to use our formula right here. So basically we know that a quadrilateral has 4 sides. So what we can do is we can take the number of sides in order to find the sum of the interior angles. We take the number of sides, which would be 4, minus 2 times 180. Okay, so again, the sum of the interior angles of this particular polygon, which is a quadrilateral with 4 sides, 4 minus 2 times 180. And that tells me that there are 2 triangles inside of this polygon. And I'll show you how that works after we complete the computation. So the sum equals 2, because 4 minus 2 is 2, times 180. And therefore the sum equals 360 degrees. So the interior angles of a quadrilateral would sum to 360 degrees. Now, one way you could think about it is, in this case, since it's a rectangle, well, 90, 90, 90, 90 add up to 360. Another way you could figure it out, especially if it wasn't, maybe they didn't have 90-degree angles, is you find one vertex. So you can pick any vertex on the polygon, and you want to draw a diagonal to as many non-adjacent sides. So from that one vertex, you're going to draw as many diagonals as you can. So in this case, I can only draw one, because otherwise if I go this way, that's an adjacent side. It's right next to it, or an adjacent vertex. And here's another adjacent vertex. And notice if I try to draw a line, it just goes along the polygon. So the only diagonal I can draw is right here. So that's 180 degrees, 180 degrees, because that gives me 2 triangles. Now, let's try one with a pentagon. So if we had a pentagon has 5 sides. Okay, and a pentagon's a polygon. It's a closed figure with 3 or more straight sides. So a pentagon has 5 sides. So let's draw a pentagon. And it's any pentagon. We're not talking about a regular pentagon in this case. It doesn't have to be a regular pentagon, meaning it doesn't have to have the same angles, interior angles, or all the sides do not have to be the same measurement. I'm going to pick a vertex. I could have picked this one, this one, this one, this one, this one. But I'm just going to pick one, and I'm going to draw as many diagonals as I possibly can to non-adjacent vertices. And in this case, this is adjacent because it's next to it, and this is also adjacent, or non-consecutive. It's right next to it, either one. And this gives me 3 triangles, so 180, 180, 180. If I have 3 triangles inside of a pentagon, that means that the sum of the interior angles would be 180 times 3. And 3 is 2 less than 5. So we could use the same formula. So number of sides, 5 minus 2 times 180. And if we do that, 180 times 3, we get 540 degrees. So we know that this angle here plus this angle plus this angle plus this angle plus this angle must total 540 degrees. Okay, the next example I have is, let's assume that we have a regular pentagon. And this may not look exactly perfect or drawn to scale, but remember, a regular pentagon, or any regular polygon, has equiangular and equilateral sides and angles. So in other words, this angle shown by tick marks, all these angles are equal. And all these measures, side measurements, are also equal. They may not look it, but I'm telling you that they are, so you have to go by the information that you're given, because I had to draw this freehand. So this is my regular pentagon, and again, we saw that in the video today, that a regular pentagon has all the same sides and all the same angles. Equiangular, equilateral. And so what the question is going to be now is, rather than find the measure or the sum of the interior angles, we now have to figure out what would just one of the angles be inside this regular pentagon. Well, we know from the last example that we found that the interior angles, the sum, is equal to 540 degrees. Okay, we proved that. Now, we need to figure out what one of these angles would be. Well, I have 5 equal angles, and I know that the total is 540. So I take 540 and divide it by 5. And so 5, and we'll just do it the long way, 540 divided by 5. 5 goes into 5 once. 5 can't go into 0, but 5 can go into 40, so 8 times. So 108 degrees would be the measure of one interior angle of a regular pentagon. Okay, now the last thing I want to go through is one more concept, and that is the exterior angles of a polygon. And we discussed how the exterior angles of any polygon will always add up to 360 degrees, because remember, the more sides you add, the closer you get to a circle. So that's one way to remember it. So the measure of the exterior angles, one per vertex, will always be 360 no matter what the polygon is, okay, no matter how many sides it has. So if we have a polygon, and let's say that the sum is 360, which we know the exterior angles, and we want to find one of those angles. So for example, let's say we have a hexagon, and I know that the exterior angles sum to 360 degrees. Well, I can figure out what one exterior angle is. One exterior angle for a six-sided figure would have to be 360 divided by 6. So 6 can go into 36 6 times. 6 goes into 0 0 times. So therefore, one exterior angle of a regular polygon or hexagon equals 60 degrees. And again, that has to be a regular hexagon, because if it's not, the other angles could be different. So remember, with a regular polygon or a hexagon, all of the exterior angles must equal the same measure.